All right, so now we are going to be collecting data on part one, which is going to be the control and the mung beans. So again, the reason we're using the control is because if there are changes in the temperature or the pressure overall of the system, then we'll be able to calculate it out for the mung beans to see what the actual change of the volume is based on the oxygen consumption. So for example, if the control that we know is not alive is changing in volume, that means that the mung beans, the volume changing isn't just based on the respiration rate. So then we would be subtracting how much this one changes into this one in order to see the actual amount of change caused by the mung beans doing cellular respiration. So I'm going to add in the initial manometer fluid, and we're going to every 2 minutes mark down the change in the where the manometer fluid is. And then at the very end, I will measure out the distances for you in centimeters, and then you will do the calculations in the table by yourself. So let me go ahead and add the manometer fluid. I couldn't add it before because if I add it too early, the one in the mung beans will actually start doing cellular respiration and change the volume already. So I want to make sure that it's as accurate as possible. And so we're doing the control one first, because if you do the mung bean one first, technically it will start doing cellular respiration, and you will not be able to calculate it out. So I'm going to add the manometer fluid, and then I'm going to draw it in to the tube about halfway. As you can see right here, it's about halfway down, or a little bit less than halfway down, since I am holding it right now, and it's going to get colder. So, and then I'm going to put it into the bath, see where it settles, and then right before I'm going to mark where it's going to, as you can see, the ice bath is a lot colder, so it actually moves down a lot further. So I'm gonna, not ice bath, sorry, water bath. So I'm going to have to push it outwards first to make sure that it's at least at halfway at the temperature that it's being held at in the colder water than my hands. Obviously, the reason why I was moving that, sorry, I should have warned you for the bell ringing. So we'll mark that after. So let me do the same for the mung bean one, and then we will go ahead and start the data collection. So again, add the fluid and then let it acclimate to the temperature of the cup again. And it's moving down because it's still currently colder in the water than it was in my hands. So I'm going to have to move it to adjust it. Ooh. Or you could accidentally move it and adjust it all the way out like I just did. So this is a pretty difficult lab to actually do by hand. So it's kind of nice that we're doing a demo version of it. And right now it's okay that they're at different heights, and the fact that the amount of fluid in them is different because we just want there to be fluid in there that is marking the location. So I'm going to mark it and start time now, and every 2 minutes I will mark it again at the base of the manometer plug to show where it has moved to. So let me go ahead and start time. as you can see already at 1 minute, the original mark for the cellular respiration with the mung beans was up here, but the manometer fluid has already moved down pretty far. So we could hit the base before we even get to 10 minutes, and that's okay. Sorry, I was just taking out paper so we could use it to see the results afterwards. And notice, like the procedure said, I'm marking the base of where the plug is to keep it uniform. If I had marked the top of the plug at the beginning, then I would be marking the top of the manometer plug throughout the entire experiment. It doesn't really matter, but they asked to mark the bottom, so I did mark the bottom initially. So I should be marking the bottom of the plugs instead of the top of the plug each time. And so we're coming up close to 2 minutes. And it does look like the control manometer fluid has moved a little bit, but that's probably due to the temperature discrepancy between when I was touching it and when I was not touching it. So we're going to mark the bottom of the plug right here, and we'll mark the bottom of the plug right here as well. Let me darken the initial one. So as you can see, the manometer fluid in the one with the cellular respiration with the mung beans is moving quite a bit already. And the reason it's moving is because the washers are heavy, but they're not heavy enough to actually keep all of this sunken because there's obviously gas inside of the cellular respiration respirometers because the plants are using up the gas, and there's gas in between the gaps in the cotton. And so again, I need to keep reiterating that this change in the volume right here is because once I added the manometer fluid, this became a sealed chamber, right? The bottom is sealed off by the rubber in the syringe, and the top used to be open like this as a tube, but once I put in the manometer fluid, it actually sealed off this opening. So any change now is evidence of a gas being used up. And remember, we did talk about how if one oxygen is used up, then technically one carbon dioxide is made, and the gases would be replacing each other in volume. So then the volume wouldn't change. But we also know now that since we put in KOH, the carbon dioxide is no longer being produced and left as a gas. It is being produced and automatically turned into a solid. So if it turned into a solid, it's no longer taking up the space of a gas, and then we are good to go on measuring the oxygen being used up. So it's kind of an interesting take on, because you would usually assume it would be easier to measure the product, but in this case, it's easier to get rid of the product and measure the reactant being used up. So again, we're coming up on the 4-minute mark, and we probably will go to about 8 minutes, a little bit over 8 minutes to collect data. And I will mark the location of the bottom of the plug, and it looks like our control one is no longer moving. So that's a good sign. So our mung bean one is still using up oxygen. It's going from 1, 2 to 3, and then here we go 1, 2, 2. So it stayed pretty much in the same area, which means we won't really have to do any calculations on the, amount of change that occurred. So we're coming up on the 6-minute mark. To be fair, if you already understand the data collection method after I explain the other parts, then you would be able to just move on and just go to the final data collection points. But as you can see, our respirometer for our control is no longer changing. So we are coming up on the 8-minute data collection mark, and it looks like our two respirometers are both not really changing anymore. So we are going to wait until the 10-minute mark to see if there's any further changes in the mung bean one, because we know that the control one hasn't been changing for a while. So basically we have 10.0, 2, 4, 6, and then 8 was the same as at 6. So we'll see if 10 is any different. If it's not, that's also okay. Oh, it looks like we had a sudden jump. Maybe it's because the inside of the tube wasn't lined very well, so then it doesn't move smoothly down. So that means that the pressure was building up and up and up and up, and oxygen was being used up and up and up until it was strong enough to pull it through the tube when it wasn't smooth for it to just move through by itself originally. And so for our 10-minute mark, we might be basically just at the base of the capillary tube, making that mark for the distance it has moved. So our measurements might be a little off because maybe originally between the 6 and the 10-minute mark, it was supposed to move a little bit and not that huge jump it just made from here all the way down. But we can account for that in our explanation when we write our conclusions. So that's okay. And as you can see, the liquid is pretty much moving into the actual end of the capillary and into the syringe, which means it will get absorbed up by the cotton inside. And we will just mark the distance as the base of the capillary at 10 minutes, which we are about to come up to. And that is 10 minutes. So I will just mark it as the base of the capillary, since that is the last point where we can actually see / record. And then obviously the one on the control didn't really change. So now we are going to actually collect our data that you'll be putting into your data table. So let me take out these and dry them so I can show you the distance that they have traveled. Now we don't need to worry about the actual manometer fluid anymore changing because we already have our markings. They are going to change though, just a heads up by the time I show you, because the room temperature is a lot warmer than the water temperature, but the water temperature is constant unlike room temperature. So it's nice to have that. Okay, so we have, let me put on a sheet of paper so you can actually see. So we have our mung bean, and we're going to use a ruler to measure out. I don't know if you can see, these are the centimeters. So we're going to be measuring out the distance of the movement from the starting point all the way out to the bottom. And then we'll do the control afterwards. So again, this is the mung bean one. So the initial movement from point 0 minutes to 2 minutes was about 2 centimeters. So that means that in your table, share screen here. So in your data table, let's go to the data table. In your data table, the water temperature bath you could mark as 20 degrees Celsius every single time. And that is going to be the same for all of them. So I would just, copy and paste that down. And if you're handwriting it, it's a lot easier. So the total distance that the fluid has moved in centimeters for this first one is going to be 2.0 centimeters. And I say 2.0 because we were pretty much exactly on the dot for 2 centimeters. Oh, sorry. This would be for the second minute. For here, obviously, for the 0 time point, it's going to be 0 centimeters because we shouldn't have moved yet. Right? Makes sense? And then for the 4-point time, that means that we're measuring it. So if you look at the point right here, we're still measuring it from the 0 time point because it's total distance moved. And that means we have moved about 3.2. We've moved about 3.2 centimeters total at this point. And then at the 6-minute time point, we have moved about, see if I can get this accurate as possible, about 4.2 centimeters total, right? So I'm still measuring from the 0 time point time mark. At 8 centimeters, we know that we actually didn't see any movement, and that might have just been because the fluid was getting caught inside of the capillary tube. And then at the last time point, we have, at the 10-minute time point, we have 5.4. So that means over here, we're going to be doing some minor subtraction now. That means the first one, obviously, the change in fluid position during the time interval, there was no time interval yet, so we have 0 centimeters. Okay. And so at 2 minutes, we are calculating the change in fluid position during this time interval, which means from 2 minutes to 0 minutes, how much did it move? You're going to do 2 centimeters minus 0 centimeters, and so you're going to get 2 centimeters because that is the amount that it changed just during this time period. I'll do one more example here. So during the 4-minute to 2-minute time period, where you went from 2 and waited until 4, we went from 2 centimeters to 3.2 centimeters. So the difference here is 3.2 minus 2, which means that the difference is 1.2 centimeters. And you're going to finish up the table doing this, and then you're going to fill out another table with the control one that I will show you. Okay, the control comes important just because this change right here and right here is all going to need to subtract a little bit because we actually had a little bit of movement. So if we go back to our main screen and just look at the control, from the time point 0 to the time point 2, we had a movement of about 0.4. We have a movement about 0.3. So that means that, guys, share again, and we go ahead and you're going to have a second data table, but I only have one right here, so I need to show you what's happening. So again, we always say we started out at the 0 time point at 0 centimeters, right? So the change is also 0. But from the time point 0 going to time point 2, we had a change in about 0.3 centimeters, so about 3 millimeters. But after that, it stayed at 0.3 all the way until the end of the 10 minutes. And you do have to record it as such. And so, for example, like the 20 degrees Celsius, I do need to rewrite it in every single one of them. So I'm gonna just cheat a little bit on the computer and copy and paste it because I can. But if you're handwriting it, it's pretty easy to also just write 20 degrees Celsius like this here multiple times. So make sure that both of your tables actually have 20 degrees Celsius for the whole thing. So now in our change, we have 0.3 centimeters minus 0 centimeters, which is 0.3 centimeters. And that means over here, 0.3 minus 0.3 is 0 centimeters, which means that there's actually no change going forward, right? Because it's the control, it's not actually changing. But we know that the reason why there's a change initially is because I was holding the respirometer, and my hand heat is higher than the heat of the water bath. So the change, I don't know why I'm writing this. It should be 0 centimeters, my bad. Talking and writing at the same time is a little bit hard. So if you notice that there's no real environmental change based on, environmental factors because we had mostly no change. But this does mean that the initial change right here from 0 to 2 needs to be subtracted from the other table. So when we said it went from 0 centimeters to 2 centimeters, it actually went to 1.7. Okay, that means everything else needs to be moved down by 0.3. So it went from 0 to 2 centimeters to 3.2. That 3.2 is actually technically 2.9 because there needs to be 0.3 subtracted from each. So while I did record the data for you initially on the other one, I do need you to go back and correct all of them and show me that you corrected all of them by writing both values, the original ones that I wrote and the corrected values next to them in your tables. So it goes 0 to 1.7 to 2.9 and so on and so forth with 0.3 subtracted from each of them. Okay. That is your data collection for part 1 of this experiment. There's going to be another video on part 2 of the experiment, which we're going to be using a different kind of seed, which is the Alaska pea, and it's a much bigger seed. So we're going to kind of see, is it going to go faster or slower in respiration rate compared to the mung bean? Because Alaska pea is about 2 to 3 times the size of a mung bean. So I do want you to write a hypothesis about us changing the type of seed and comparing the Alaska pea respiration rate to the mung bean respiration rate. Now that you have kind of a good gauge on what the mung bean respiration rate is, I want you to kind of, say, if it's bigger, will it be faster or slower than the mung bean? And prepare 2 more data tables. One should be Alaska pea respiration this time, and the other one should still be the mung bean respiration rate because we're going to be comparing both of them to each other in the next experiment. And then I will introduce the summary and conclusion in that video.